Okay, here we are. Just some factoring techniques that we can use. This one I think is just a greatest common factor problem, isn't it? So I think what we're going to do is this. First, we're going to look at the numbers 12, 20, and 32. What's the greatest common factor of those three numbers? Think about this for a second, and if you're not sure, then start factoring one of them and ask yourself what you get. So we have 1 times, I don't know, 1 times 12, right? 1 times 12, 2 times 6, 3 times 4. Got to 3 times 4. The next question I was going to ask myself is 4 times something, but look, I already have that. So usually I put a little something, a little circle, a little dot on it, a little something to say I trap myself. I know I have all my factors here. Which of these are factors of 20? Well, 1 is, 2 is, 3 is not a factor of 20. 4 is a factor of this one, and this one. Is 4 a factor of 32? It is. Is 6 a factor of all of them? It is not. Is 12 a factor? Therefore, the answer is here 4, right? So I'm putting together my greatest common factor. Wow, that's terrible handwriting, buddy. Putting together my greatest common factor. And so far, I have 4. Now I'm going to look at the a value here. Does this one even have an a value? It does not. Neither does this one, so I can't factor out an a value. This has x cubed, this has x squared, this has x to the first. The least of which that they all share is the greatest one that each one of them has. So the greatest one that all of them have is x to the first power, so we'll take out 4x. Then we just start to rebuild this. So I'm going to take this 4x right here, and I'm going to put it here. Then I'm going to start to rebuild this thing because we don't get to change the answer. We just get to change its form. And I'm going to ask myself, 4x times what is 12a cubed? Well, 4 times 3. We don't have a factor of a here, so we need one here. And x times what is x to the third? Well, x squared, right? Because we add these. So this is x to the 1 plus 2 is x to the 3, right? I'm going to move on to the next term, and I want to ask myself, 4 times the number that's going to go here is positive 20, and that would be 5, wouldn't it? We don't have a b value factored out because we couldn't get one because they don't all have one. So there's our b. And then the next question is x times what is x squared? And it's x times x, isn't it? Moving on to the third one. Ask ourselves, 4 times what number is 32? And I believe that that is 8. We don't have a c factored out here, and we need one here, so we have to put it in here, right? And x times what is x? It's a 1. In my mind, it kind of looks like this. It's this, right? It's 8 times c times 1. But we don't need to put that, but that's kind of what helps my brain to put that away well. We're going to check our work here and see what's the greatest common factor of 3, 5, and 8. Well, the greatest common factor of 3, 5, and 8 is 1. The greatest common, none of them share a value of a. 2 of the 3 of them have a factor of x, but that only works if all of them have it, so I think we've done a good job here. Let's try another problem, please. So we're going to factor this next polynomial. Factor the polynomial. And this polynomial looks like this. So here's example 2. Example 2. Example 2, if you don't mind, is going to be 4x squared plus 14x plus 6x plus 21. I'm looking at this. We talked about this in the last video. When do I get used to seeing this? How do I know which factoring technique to use? And I'll tell you now what I told you then. It's unfortunate to say that you just have to get used to it and you have to really, really work on this. So I know we can't, this doesn't have a factor of x in it, so I know I can't factor out an x. 4, 14, 6, and 21 are called relatively prime. That means they don't share any common factor other than 1. So that doesn't work. So I'm going to try factor by grouping here. And this is the way I'm going to look at this, as always. I'm not going to change the sign of anything inside the box, and I'm going to put a plus sign here, which changes absolutely nothing. I want you to think about that, because this is a positive 1, and positive 1 times this mess changes nothing, does it? And then I'm going to try to figure out what's the greatest common factor of 4 and 14, and I think it's 2. What's the greatest common factor of x squared and x, which is just x, isn't it? And then I'm going to start trying to put this thing back together. And 2x times what is 4x squared? Well, that would be 2x, wouldn't it? And 2x times what is 14x? Well, that would be positive 7. Isn't that right? Now we're going to do the same thing here. What's the greatest common factor of 6 and 21? And that would be positive 3. Right? So let me help you to see this better. Positive 3. I'm going to put it back together again. If you're wondering why I'm using square brackets, because they're just parentheses, and you can use any shape you want as long as you use them consistently. 3 times what is 6x? Well, that would be 2x. See any similarity here? A 2x here and a 2x here. Wouldn't it be great if this value over here turned out to be positive 7? And guess what? 3 times what is positive 21? Positive 7. Whoops. I said you had to use the same one, didn't I? Okay? So what do we get out of that? We get the factored form of this is 2x plus 3, this thing plus this thing, times 2x plus 7. And if you're wondering why I get to cancel one of those out, I can show you quickly that I did this. Just followed the work here. I did 2x times 2x, and that's this 2x times this 2x, isn't it? I did 2x times 7, and that's this 2x times this 7, isn't it? And then we moved over here, didn't we? We did 3 times 2x, but look, here it is. 3 times 2x, the same thing. And we did 3 times 7 here, and we did the same thing here. We've just combined this and simplified it, okay? And I challenge you to FOIL this out. If you FOIL this out, I promise you, you're going to get this. All right? So keep practicing. Take good notes.